Hi guys, today we are looking at the differentiation rules for sinusoidal functions. Okay, so far what we know is that if the original function is sine x, then the derivative function is cos x. Now we're going to look at compressed functions today and functions that have been shifted, etc. So I said now if the original function is sine 2x, what do you think the derivative will be? So I have on the screen here the graph of sine x, which is in blue, and sine 2x, which is in red. I said, okay, what do we notice about the slopes of the tangents of the two graphs? So we notice a couple things. So first of all, if I just look at the places where the tangent is 0, so we have 0, 0, and then I'll look at these 2 points here, 0 and 0. Okay, we notice that the x values on the red graph are half of the x values of the blue graph. Okay, so that means that the derivative is compressed as well. So we say first thing we notice is that the derivative function is compressed as well. Okay, and the second thing we're going to notice is if what we did yesterday, if we looked at like the x-intercept on the blue graph there, right, and we sort of drew a tangent line, and we figured out the slope of the tangent, we pretty much got that that was equal to 1. Now, if we look at the red graph, right, let's sort of try to draw a tangent here. So it's going to look something like this. Okay, and now if we draw our right triangle, come down and go across, okay, we'd have it, the height of it is 2, right, from 1 to -1 pretty much is 2, and then from there to there is approximately 1. So the slope of the tangent at the steepest point is equal to 2. So the second thing we're going to notice is that the slopes of the tangents are doubled. Okay, this means that the amplitude is 2. So therefore, if f of x is equal to sine 2x, then the derivative is going to equal cos 2x, okay, and then we're going to times it by 2. So it's going to be 2 times cos 2x, right? So the amplitude of this one is 1. The amplitude of the derivative is 2. Okay, so in general, if y is equal to sine of some function of x, in this example was 2x, then the derivative y prime is going to equal cos f of x times the derivative of f of x, and that's the chain rule. Okay, similarly, if y equals cos f of x, then the derivative is going to be negative sine f of x times f prime of x. All right, so let's try some examples here. So first one, y is equal to sine 4x. So these derivative here, they all have 2 parts to them, right? So the derivative, okay, so y prime is equal to, so we do the derivative of the function first, so it's going to be, I'll write them in square brackets here, you don't have to, so it's going to be cos 4x times the derivative of the angle, which is 4. And then we just write it as 4 out front cos 4x. I don't have to put the 4x in brackets, but you can. Okay, next one, we have a constant out front, so that's going to stay. And then the derivative of cos, so it's 2 steps again, so it's going to be negative sine pi x times the derivative of the angle, which is right here, and it's going to be times pi. We're going to write it as negative 4 pi sine pi x. All right. Now this one right here, the function is a little bit more complicated, right? This one was just 4x. This one here was just pi x. This one is now x cubed plus 2x. Not a problem. Y prime is equal to, we do the derivative of the function first, so it's going to be cos of x cubed plus 2x. Again, I'll put that in square brackets, times the derivative of the function angle, which is 3x squared plus 2. Okay, and we can leave it like that, or we can write it out front. That's fine. Okay, next one. Derivative, we have the 2 out front. We have cos 3x plus 2 times the derivative of the angle function, which is just 3. And then there's no derivative for the plus 1 because it is a constant. Then we simplify by bringing this and combining it with the 2. So 2 times 3 is 6 cos 3x plus 2. Done. All right, now we're going to take it a step further. So it says now we'll investigate the power of a function rule. So recall, if y is equal to f of x to the power n, then y prime is equal to, look at, we have an extra step in here. You take care of the power first, n, f of x to n minus 1 times the derivative of the function. So with that said, what if y equals sine squared x, what would the derivative be? So you just have to understand here that this is the exact same thing as writing it like this. And actually, it's probably easier to write it like that before doing the derivative, but whatever. So the derivative is, okay, we take care of the power first, so it's going to be 2 sine x to the 1, part 1, times the derivative of f of x, which is cosine x. So y prime is going to equal 2 sine x cosine x. Done. All right. So the first couple are 2-step, and then we get on to 3-step. These are the part C, that's the most difficult type. Okay, so derivative is, so again, step 1, take care of the power, so it becomes 3 cos squared x. That's step 1. And step 2 is the derivative of cos x, which is negative sine x. That's equal to negative 3 cos squared x sine x. See, 2 parts, 1 and 2. Okay, next one. Y prime, we have a constant out front, stays there. Then we bring this out, so times 4 sine 3x, step 1. And then step 2 is the derivative of sine x, which is cosine x. So that gives us 8 sine cubed x cosine x. Okay, now this one right here, we have a power and we also have an angle, which is a function of x, not just x. So there's an extra step here. After you do this, then you have to multiply it by the derivative of the angles. This is a 3-part question. So derivative is equal to, I'm going to write them like 1, 2, 3 underneath. So derivative of the first one is going to be 3 sine squared 2x plus 1. That's part 1. Times the derivative of sine 2x plus 1, which is going to be cos 2x plus 1, times the derivative of the angle, which is 2. So we're going to end up getting 6 sine squared 2x plus 1 times cos 2x plus 1. All right, so this is a 3-step. 1, 2, 3. I just didn't have space there, but the next page I'll have space and write them all in a line for you. All right. So here's another one here. I should have spread that out more, but that's okay. So the derivative is step 1, take care of the power. So it's going to be, I'll put them in square brackets here. So we're going to have 2 cos 3x plus 1. Step 1. Step 2, derivative of the function, negative sine 3x plus 1. Next part, derivative of the angle, 3. And then we simplify it, so we're going to have 2 times negative 1 times 3 is negative 6 cos 3x plus 1 sine 3x plus 1. Okay, and next one here, you should have space to do it. Y prime is equal to step 1, 2 sine cos x. Step 2, derivative of this, which is cos x. And step 3, derivative of the angle, which is negative sine x. We simplify it to be negative 2 sine of cosine x cos of cosine x times sine x. 3 steps. All right. Let's take it a step further now. Let's do the product rule. So for the first one, we'll go on the side here. We'll call this F. We'll call this G. We'll call this F, and that's G. That's F, and that's G. Okay, so we'll do on the side here. So we'll do F prime. We'll do F prime and G prime. So F prime is equal to 1. G prime is equal to cosine x. Okay, and then we get Y prime is equal to F prime 1 times G plus G prime times X, or F, so it's X cosine X, which is equal to sine X plus X times cosine X. All right. Next one here, F prime is equal to 6x squared. G prime is equal to negative sine 2x plus 1 times 2, or negative 2 sine 2x plus 1. Okay, so write it down here. So we have Y prime is equal to F prime times G plus G prime, so it's actually minus times F, and we get 6x squared cos 2x plus 1 minus 4x cubed sine 2x plus 1. All right. And the last one, okay, actually, sorry, I made a mistake here. I'm going to change that to a T. Okay, so F prime, simple, 2. G prime is 3 sine squared 4t minus 1, part 1, times part 2, cos 4t minus 1 times part 3 is 4. That's equal to 12 sine squared 4t minus 1 cos 4t minus 1. All right, let's put it all together. Y prime is equal to f prime 2 times g sine cubed 4t minus 1 plus g prime 12 sine squared 4t minus 1 cos 4t minus 1 times 2t. And just about done. 2 sine cubed 4t minus 1 plus 24 sine squared 4t minus 1. Again, cos 4t minus 1. Done. Try those questions. Enjoy.